Okay, so everybody, we're going to get started on this one. The purpose of going over number 7 is because this is the first example that we would have covered in this packet where scale factor is not going to be very helpful because of a few reasons. Number one, we have decimals, which you can certainly get a rounded decimal scale factor, but that's not as effective as having the exact value. The other reason is a side like this one here, where df is a sum of two things, which means we're going to get an expression. So scale factor is tough to deal with here. So we're going to lean on that idea of being able to create a statement of proportionality from a similarity statement. So in this question, though, unlike previous examples we have, we're not starting with a similarity statement, so that's our job to take care of first. We are trying to prove first that triangle ADG is similar to DFE. With E up top here. So what we want to do first is we have to prove, to show that these triangles are similar, we have to show that all of their angles are the same. Well, we're given one congruence to start. We're given that angles A and F are congruent to each other. So we have to find one more congruence because, of course, the third angles theorem is going to tell us the third angles are congruent. So where we're going to find that last congruence, or the second congruence rather, is right here with angle D. Both triangles, DAG and DEF, share angle D by the reflexive property, if you remember that from triangle congruence. So that explains why those angles are the same. From there, the remaining angles, angle G in this triangle and angle E in this triangle, have to be congruent by the third angles theorem. So we have two triangles where the angles are the same. So they are similar. So now what we're going to do is we're going to write a similarity statement right up top. Remember that your parts must correspond, so it doesn't matter how you write the first one. I'm going to work on the smaller triangle here. I'm going to call this triangle DAG. And now what I have to do is I have to make sure I match up parts. So angle D is clearly corresponding with itself in the yellow triangle. Angle A is up here. That's marked red with one marking. That corresponds with F. And that leaves us with G and E corresponding as well, our purple angles. So we have our similarity statement. This is where we normally start. And I've been mentioning to you that when you have a similarity statement, you should just use this and not look at the picture to produce a statement of proportionality so that we don't let our mind kind of fool us into thinking certain sides correspond with sides that they don't. So what I'm going to do is I'm not even going to, I mean, I know it's on the screen, but I'm not looking at this right now. Instead, I'm solely looking at our similarity statement. And from that similarity statement, I'm going to produce a statement of proportionality. Segment DA is in the same position as segment DF, so they must be proportional to each other. So there's our first proportion. Segment AG, same position as FE, so they must be proportional to each other. And then lastly, we have DG and, of course, DE in the same positions as each other. So I pull this statement of proportionality directly from the similarity statement. I'm not even looking at this picture when I do that, because this similarity statement tells us everything we need to know about the triangles and what parts match. From here, before we start solving for x, which is here in our triangle, before we start solving for y, which is here, I want to fill this statement of proportionality in with all of the information. So now I am going to go back to the picture just to gather information. So what I'm going to do here is I'm going to write my statement of proportionality like maybe here, filled in, so we then can use it for part C and part D. I'll use a finer point here. Segment DA is right here. That is 7.67 centimeters. Segment DF is right here. It is the two of these added together. This is X and 5.61. Whenever that happens, we add them up. So we're going to put in our bottom here x plus 5.61. So you see now we have our expression. It's not going to be easy to work with scale factors when you have this kind of thing happening. AG is where we find our y variable that we're going to ultimately solve for. FE is right here. That's 8.76. And then we have one more proportion left. DG is the small one here, 5.61. And DE is from here to here. So again, we have another situation where we are summing things together to get DE. we get, I believe, 11.38 when we add those two numbers together. So now we're ready. We have our full statement of proportionality filled out. I don't have to look at the picture now again to solve this problem. So the fact that this is embedded, the fact that this is like contorted, it's rotated, it's not relevant anymore because I have all the information I need to set up proportions right here. And I got it simply by setting up a similarity statement to start the problem. So either you're setting up a similarity statement or even easier, you're given one. This is all the information you need to set up one of these problems. So now we're going to go ahead and actually do the work. We're going to solve for x over here. We're going to solve for y over here. We'll solve for x in blue. For x, I think I need this proportion, and I think I need this proportion because this includes the x variable. This doesn't have any other variables, so that'll work. So we get 7.67 over x plus 5.61. That's going to equal 5.61 over 11.38. And this is when I'm going to have to slow down for a second to do this calculation. But before we do that, we're cross-multiplying. So I get these two products. First one is definitely, I'm going to write as a pair of parentheses first, 5.61 times, we're going to have to erase this. The product of these two means I must make sure I'm multiplying everything by 5.61, not just the x variable. And then that's going to equal the product of 11.38 and 7.67, which I'm going to do on the side here. 87.28. I'm going to round everything to the hundredth as I'm doing my work here. So 87.28. This is just going to hang out. Now we're going to distribute 5.61 times x plus 5.61 times itself. 31.47. Again, rounding everything to two decimal places, the hundredth. So now we have a single linear equation here where we have to get the numbers over to one side and then divide by the coefficient. So the next step is to subtract 87.28 minus 31.7. So we'll do that real quick. You have 55.81. And then we're going to divide both sides by 5.61 for that little x variable there. Let's clean that up a little bit. There we go. And then we're dividing both sides. Now I'm going to use the approximately symbol now, although I kind of should have already. The approximately symbol here, this double squiggly, means that we're rounding our answer, again, to the second decimal place. So I'm going to divide by 5.61. We get 9.95 as our answer for x. There we go. All right, now, luckily, like this was the one with the bulk of the work because of this expression. To solve for y is a little bit simpler. I'll do that in a different color. We'll use red because I need this one because y is involved. And then I'm going to go back to this one again because I don't have any x variables involved, even though I know x now. No reason to add it in there and plug it in. I already have this set up, so this one's a little bit more straightforward. We just get to cross-multiply and divide. So this is going to be quicker. 5.61 over 11.38. When I cross-multiply, I get 11.38 times y. And then I'm going to multiply 5.61 times 8.76. That's going to give me 49.14, rounded to two decimal places. And then we're going to divide both sides by 11.38 to get another approximation here. And that's 49.14 divided by 11.38. Obviously, we've rounded a couple times at this point. And I get, as my final answer, a very rough approximation, we get 4.32. And there you have it. So we're starting our problem by setting up our similarity statement. This is crucial. From the similarity statement, we get a statement of proportionality. From our statement of proportionality, we just go back to our picture at that point and we fill it in. And then what we do is we just select the proper proportion set of proportional equations to solve. Scale factor is not going to help with questions like this. So you have to, at this point, really commit to writing these proportions out.